I hope you can hear me now and it's not so delayed as it was before. I have remade my setup, so just give me a second. I will again double check what's going on using different devices and different setups. So one thing to listen to myself. And again, this delay. So yeah, by that time when I was frozen, I did some additional learning how to work within the Livestream setups in LinkedIn. So I'm sure we will manage on some stage how to do them. So let's go to the next screen. And the next screen is actually my presentation. So let's hope this part will be not frozen. Will not be frozen, and you will be able to see me and hear me. And or if not, I know we are just that stubborn people that we will definitely do it today. So my plan, if this presentation will not be proper, then we will probably go to YouTube and I will do the live stream over there, because it's the road which I know how to go. We have done a few already, but let's see, maybe everything will be alright and fixed here. And yes, one more apology for all these technical issues. But as I mentioned, the people who are doing something first time, second time, third time, even fourth time, and up to, I don't know, 100 times, it may be sometimes not so smooth, but let's hope it will be on some stage already smooth. So not clear again. Yeah, this is just about the delay, so maybe I will try, because in different platforms they have hacks how to just the image again is delayed on my side. So what is going on? Why it's delayed? Not sure why. Maybe there is some kind of opportunity to speed up. So let's see the opportunity. I can even just ask about what is the overall traditional delay in just a second. Maybe we will get some answer from very smart assistants. Okay, so while we are getting the responses, we are now trying to see how the screen is working, and can you see everything through it? Oh yes, I can see that you finally can hear me and see me. Good. At least finally. Yes, and assistant is working, so let's go back and do this, our presentation for today. And I want, first of all, I already mentioned this in this event, which was at the beginning. So yeah, unfortunately this is not pleasant experience. Sorry about that if you have joined me first time. So this time it will be more different, I hope. So please, if you want to ask any question or do any comment, add them there, specifically if you experience some delay with sound or video or any other challenges, because I read everything which you write, because then I try to fix this, and now the more I do this, the more I learn. So it will be like that very well-known quote that the expert is a person who not just know all the mistakes, but the person who have done all these mistakes. But anyway, I would like to start with the big thank you to those people who already have helped me a lot, and during my previous live streams you commented, and your comments made a difference for me. So thank you for helping me to get to the next level. So thank you Kashif Zaman, Haysam Radiyadine, Rona Weldon, Mustafa Salabi, Rajul Patkar, and also I would like to thank you Sausan N, Pratik Harat, Divyanshi S, Dr. Khulipala Ravindra Babu, thank you Alexander Slisarenko, and thank you Dr. Osama Saliman for your comments and for your help in my previous live streams. And I'm sure that together with our all this work, mutual work and mutual desire to have proper quality of live streams, we will get better experience. Good, then let's just go to the subject, because the subject is, as it was announced before, it was leaf area measurement of compound leaves. At the same time, I decided that we maybe not go just very broad, and we focus on one specific plant and one specific crop, because in my side we are obviously supporting the non-agricultural plants, but in many cases and in most major of the cases we are speaking about still crops which are agricultural, which are grown to feed humans and animals, but it's all about the industrial application of agriculture, not just about the plant science as it is and about botany, but still we have some interesting cases about botany. One day when we will have proper live streams, we will speak about them as well. So let's go to the next point. And as I mentioned, yes, my description of previous event was about the nice, beautiful parsley. So I have it. I have my parsley, flat leaf parsley, and I have not just, I have a bunch of it. So here you see, I purchased in local supermarket nice bunch of parsley, because this is the point that my plans were much larger, not just to show you the presentation. I also wanted to demonstrate the measurements in real life, and we will do that. One day we will do that, but even now I was suggesting that probably if there will be an issue, so I added some screens, and it will be helpful for you as well to see. So we are focusing on measuring compound leaves on the example of parsley. And just a reminder, compound leaf, it's a leaf which is not simple one shape, for example, like this one. This is like cherry leaf, but compound leaf of parsley, as you can see, we will now take one and just demonstrate the, yes, maybe not perfect one because it's not proportional, but you can see here that it consists of more than one parts, and there is even official name of these parts, but I mean that this is always an opportunity, and these parts are called pinnate subunits. So and this is always a question and an opportunity for compound leaves, either to measure just the whole leaf, like unified object for measurements, or you can go a little bit further and take the pinnate subunit from each part of the full unit, and then you can just measure the area of these subunits. And basically we can do this. I will just, in my previous preparations, I was like scheduling the half of an hour and everything was very nicely scheduled and properly scheduled. But as of now, it's a mess in time, because obviously I spent more than 20 minutes just trying to fix the live stream. One more thing, I will do a quick check. Do you still hear me and see me? It seems like you can hear me and see me. So good. Let's just continue. So we are continuing with our parsley, and here we have. So I will try just to do as much as I can show you with parsley today. So it maybe will be a little bit not like that timing which I officially announced. So, but the question also is that you can always think about application. So when you measure leaf area, you have already known why do the leaf area. If not, we have spoken about this on the first time of live stream, second time, and the third one. It's all about seeing the feedback from the plant to the changes of the environment, or its reaction on something which is either disturbing the plant, or if the plant is healthy and happy, it means that it's not disturbed by anything and just growing and enjoying life. So it's always the demonstration of plant status. So that's why the area is in a parameter which is important when you're trying to figure out what's going on with your plants. And yes, there are different methods how to measure leaf area, and we have lots of videos on this topic because we are doing this starting from 2013. So can you imagine, yes, in that very early stage we still were using mobile application for leaf area measurement. During this trying to fix the problem, I grown with my devices everywhere. So just a second, I will show you once again. But obviously we will, here is already a parsley which I was measuring for today. But I mean, leaf area, this is the mobile application which we have developed specifically for this one of the parameters. We have another one, but we'll not focus on them today. So, and yes, there are different approaches how to measure, but just if you would like to follow the scientific way and more standardized way, which I recommend you to follow, because the more traditional approach is already checked by many brains, very smart brains, and if they already use it for years for specific type of measurements, then probably it makes sense. So you can always follow the Petiole protocol. You can always use the different other devices like ImageJ or Fiji. It's a software which is used widely in the scientific community. But my goal today is to show you another alternative device and another alternative application. It's called Petiole Pro, and as I mentioned, we have developed it. We have research papers, more than 190 research papers which are referencing to our mobile application, and this is the reason for us to be proud, but not just proud, but to work more and work on additional capabilities of Petiole, what we are doing currently. So guiding the task of measurements of compound leaves, and specifically measuring the parsley. Just give me a second, I will take another piece of leaf. So we'll have, so here we are, another part of plant. And you, as I mentioned, you can always either take one unit and measure it, or you can take the full unit, but also you can decide, do you need to measure Petiole, which is like a part of the leaf or of this leaf, or do you need to include patches as well or not. So it depends on your tasks, on your methodology, on the goal of your research. So if you are a young researcher, please get advice of your colleagues as well as your supervisor. But there are both opportunities and both ways, and there is no right or wrong way, because everything depends on your specific experiment design. So when you are doing the preparation of your research, you already brainstormed the idea, then you can just do it and decide do you need or you don't need to include the patches and Petiole into the measurements. And also you can even ask for advice from the AI assistants available. At the same time, I would like to highlight that you need to double check the result and ask more than one AI assistant, as well as still the final decision is yours. So please be a responsible person who is using AI assistants, and please don't trust blindly to every advice which you get from all of them. When I say all of them, I mean a list of YouTube. On Saturdays I had this live stream where we are trying to test different AI assistants on the responses to the same prompts. So previously we have I asked AI about like measurements, counting. This time I was also asked about the answer for specific prompt. So then we are trying to compare how the good answers are, and in most cases they are pretty okay, but sometimes you still see the difference. So that's why when I mentioned that when you are using AI assistant and specifically you are trying to solve some important challenge for you, it's always nice to have the second opinion. So ask one assistant, but then you can always go to another one, and specifically if you don't know which one to go, maybe the type of live streams can show you which are providing more reasonable and more realistic responses. Yes, and maybe on some stage I will publish, like, is the top 10 on reasoning in agriculture or something like that, but let's see. Anyway, let's go back to our Parsley, and getting the leaf area measurement. As I mentioned, it's one of the proven yield and stress metrics. So that's why when you are measuring, you can see the difference of for example, the performance of some specific setup which you are trying, or you can get other basis for comparison. This is the point, that you are not just doing measurements for the measurements. You are just trying to compare something, and this quantification of plant growth, it helps you to go to the next conclusion which you need to make in your research. And also when we speak about the measurements, yes, this is about Parsley now. So and Parsley is quite unique and specific and niche crop. At the same time, even to this crop, it's already the level when there is kind of more advanced research, and obviously 3D phenotyping is one of the emerging directions. At the same time, when we speak about the practical level and production level, then we see that 3D applications are more effort, they require more efforts, and they require more time and more employees to be involved into a practical pipeline for using it on a regular basis. And obviously as equipment, it costs money. So that's why this is a very nice way how to do the research part. So for the research 3D plants and research 3D imagery of any type of crop is a revolutionary one, and it's the future. At the same time, when we are just trying to be somewhere in the middle, then we are speaking about the plant phenotyping of 2D objects, and 2D means photo. So this is how the current state of the art looks like. It's about the measuring the leaf area using ordinary RGB photo. Sometimes you can take the photo with different devices, which are not just RGB, but they provide the other bands as well, and multispectral devices or hyperspectral devices. At the same time, for generic, not generic but general purposes, it's okay just to have these photos and get the leaf area measurement of the object as it is, without these additional bands. And the next point, leaf area measurement is possible, you can do it manually. And there are different methods how to do manually the leaf area measurements. Specifically, there are formulas. We will not go in depth using that formulas now because we are focused on different projects, but you must know that they exist. So, and there are some research papers, nice research papers, which go in depth into using length and width for measurements. At the same time, considering that we are trying to implement the computer vision into this process of leaf area measurement, this is how the outline of Parsley leaf looks like. And when you will see how I did the measurements, you will see approximately this image, and this is a good news. But obviously you will see some limitations, and the main limitation is that the leaf of Parsley, when you are taking the photo, the subunits are overlapping with each other, and this means that the gaps which are created between the overlapped subunits, they are included into the area, and this may be the problem. And it doesn't mean that you are just doing, even you have this challenge with specific device, because if you are doing again either ImageJ or Petiole Pro, the challenge is the same, because in ImageJ you are trying to figure out the threshold, but still you are not able to exclude that area, which is, for example, on this photo which you see now, on this slide which you see now, there are white beads between the green leaves in the central part. So in most cases they are included, and it requires additional customization for this type of leaf area measurements to exclude these white areas which are created, and they are unintentionally created because of this overlap. And again, we're speaking about 2D imagery. We are currently not speaking, because obviously if you will look at the Parsley plant, it's not 2D. You can see the shape, you can see the size, and it's 3-dimensional, not 2-dimensional. At the same time, when we speak about this current application of leaf area measurement, we speak about the flat leaves and measuring this type of object, not considering that they are not flat, because then the error is introduced and it's not good. Then, yes, as I mentioned, there are nice methods with my calibrating, because our calibrating plate looks like this, and you can also, here I have this nice, I will just go closer so you can see. It's grid paper. So this paper is one of the popular methods how to measure, and it's quite accurate. So you can accurately count, but it just requires a lot of time. Another method, as I mentioned, there are soft bar. You need to have the scanned or photo of leaves. But again, Petiole. Here is my device, which I traditionally show. So now we'll go straight to the Petiole point, and I will show you here how to measure leaf area. Obviously, I can do this in parallel here as well, but firstly I will finish presentation, and then I will again, fingers crossed, I will go to the big screen, and then I will show you how it works. So, regarding the Petiole Pro, it's already the algorithm which is existing. You don't need to add anything, just launch it and take a photo from your any type of device. You can take with iPhone, you can take with camera, digital camera, any type of device which can make photo. Just not to use any type of lens which is creating kind of fisheye effect. So you need to be cautious, because then it can be the shape of the leaves can be changed, and this change may be not the correct one. So please use the ordinary photo camera to taking photo. And then you also need to have the calibrating plate, which I already demonstrated to you. So we have plenty of them different, but this one is the traditional one. And yes, in the comments I will place the link to calibrating plate. So you can just have it as well, print it on any printer, because originally you will get this one, which is just without any type of green circles, because in this one you have green circles, and green circles are only green measurement. But it's a separate story, we will not go there. So for leaf area measurement, you need just to have this calibrating plate. It's kind of a ruler which helps to get the correct measurement. And then you place, as you can see on the left hand side, you can place the leaves on the calibrating plate or next to the calibrating plate. And yeah, this is the point where